This is our senior project video. Our project was focused on improving a prototype viscometer that was created the semester before. The improvements that we wanted to make was in the accuracy of the viscometer and the keep it inexpensive, as the previous team did. Our viscometer worked on the Couette principle, in which a cup would be filled with fluid and a spindle would be placed inside the fluid, creating a small gap where the fluid interacted with both the cup and the spindle. This critical gap, as we call it, of fluid would resist the motion of the spindle, and from that resistance we could derive viscosity. However, that gap must be maintained the same all the way around, meaning that our device had to be very concentric. So the previous design, or the original prototype that we were given, was fairly concentric, but it didn't have a lot of adjustability to allow you to set the concentricity. Furthermore, the electronic setup was very complex, requiring multiple users. So from here, the team split up into two teams, two groups that worked simultaneously. The first was the mechanical group that brainstormed ideas, designed models in CAD, and then manufactured those models. The second group was the electronics group that worked to simplify the electronics, find the right parts that were needed. They wired it up and realized that the data we were getting back, we weren't very confident in the accuracy we were getting. So they ran an uncertainty analysis to figure out how confident are we in the results we are getting. This led the electronics team to create a full circuit diagram in which an analog to digital converter was used to increase the range of viscosities that we could measure accurately and well. So here is a video of our viscometer working accurately and well. There is water inside there. You just can't see it because it's clear. And here is another video, but this one is in slow motion. You can see as the spindle spins, a little light flashes every time to show that one rotation is being recorded. And so here's a perfect example of the mechanics and electronics working together in unison. The bill of materials was calculated to be $132.45, which is well under the $500 that we were given at the beginning of the semester, meaning that our design could be very profitable and very good. We fulfilled our design objectives, and this was a really good project.